Imagine the ability to type a simple sentence into a computer and instantly receive a complete, playable video game. You could describe the genre, the mechanics, and the story, and within moments, a fully functional project file sits ready for you to run. This is the promise that has driven the most ambitious research in artificial intelligence for game development. It is the holy grail of procedural content generation. For years, we have seen tools that can write a single script or generate a texture. But the leap to creating an entire ecosystem where code, logic, and assets coexist is a massive hurdle. This is the frontier where agentic pipelines are currently testing their limits, specifically within the Godot game engine. To understand where we are, we must look at the benchmarks that define the current state of the art. Researchers have developed evaluation suites like GameDevBench, which contains over 100 complex tasks designed to test what AI agents can actually achieve. The results from these tests reveal a distinct pattern. Agents are surprisingly capable of handling gameplay logic. They can write the code that makes a character move or a score counter update. However, when the task involves graphics-heavy assets or complex physics interactions, success rates drop significantly. This suggests that the bottleneck is not the ability to write code, but the ability to synthesize the complete sensory experience of a game. The current consensus is that agentic game development is a rigorous testbed for advancing artificial intelligence beyond simple coding tasks, yet a significant gap remains for fully autonomous systems capable of synthesizing complete, playable projects from raw text. The shift happening in this field is moving away from static code generation toward iterative, multi-step workflows. In the past, a system might take a prompt and output a block of code in one go. If it failed, the process stopped. Now, we are seeing the emergence of agentic loops where artificial intelligence agents autonomously plan, write, debug, and test code within the engine environment. Think of this less like a printer and more like a construction crew. A printer lays down material based on a blueprint. A construction crew reads the blueprint, lays the foundation, checks if the walls are straight, and if they are not, they fix the error before moving to the next floor. These agents use feedback mechanisms to improve their output. They write a script, run a test, read the error log, and then write a correction. This iterative loop is what allows for functional completeness rather than just syntactic correctness. A critical piece of this architecture is how the agent interacts with the game engine itself. We are seeing the integration of agentic coding models directly into the Godot editor via plugins. This enables real-time context awareness. Instead of the artificial intelligence working in a vacuum, it can read and modify existing project files dynamically. It knows what files are already there, what resources are loaded, and how the project is structured. This allows the agent to treat the game project as a living document rather than a static text file. It can navigate the folder structure, understand the relationships between scenes and scripts, and make changes that respect the existing architecture of the project. This context awareness is vital for scaling from a single script to a full project. However, the complexity of the task means that generic prompts are rarely enough. We are observing the emergence of specialized skills for specific genres. A system designed to build a horror game will operate under different constraints than one building a racing game. Horror games require specific lighting setups, sound triggers, and pacing logic that a generic system might miss. Successful agentic game creation relies on these domain-specific templates rather than broad text-to-code prompts. This means that future pipelines will likely need to carry a library of genre-specific rules that guide the agent on what constitutes a valid level for that specific type of experience. Despite these advances, there are significant limitations in fully autonomous game generation. The primary drivers of this difficulty are the complexity of integrating visual assets and physics logic. Current models struggle to generate the actual image files or 3D models required for a game, and even if they could, integrating them into the physics engine without breaking the simulation is a complex problem. This suggests that future pipelines will likely couple large language models with dedicated asset generation models. Alternatively, we may see a return to human-in-the-loop validation where the AI handles the technical scaffolding, but a human validates the creative choices for complex mechanics. The current literature validates the difficulty of the task and the efficacy of specific feedback loops rather than detailing a functional, end-to-end pipeline that works flawlessly out of the box. Looking toward the future, trends point toward a hybrid game master model. In this architecture, agentic artificial intelligence handles the technical scaffolding of the game, managing the code, the build process, and the asset integration. Meanwhile, a static or rule-based artificial intelligence manages narrative consistency. This combines the speed of automation with the coherence required for role-playing experiences. It acknowledges that while a machine can build a level, maintaining the story flow across that level requires a different kind of logic. This separation of concerns allows the system to scale. The technical agent ensures the game runs, while the narrative agent ensures the game makes sense. This evolution is not just about making games faster, it is about changing how we think about software creation. We are moving from a model where the developer is the sole architect to a model where the developer is the editor. The artificial intelligence handles the heavy lifting of implementation, and the human provides the direction and the creative constraints. This shift changes the role of the creator from writing every line of code to curating the environment in which the code is written. It allows for a higher level of abstraction where the focus is on the design of the experience rather than the syntax of the language. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.